So homework from number 11. Kenzie, I do see a negative number, not exponent, number right there and right there. Is there an exponent on this negative?
Yeah.
What?
A.
That's there. Is there first of all, what's the negative in front of? The A?
No.
What's it in front of? The number 8. Is there an exponent right there on this 8?
Oh, no.
No. So is there an exponent on that negative? And even if there was an exponent right there, this would have to be in brackets to let me know that that negative was on the exponent. In other words, this negative is going to stick around because there's an invisible 1 right there, and 1 is odd. This negative right here is going to stick around because there's an invisible 1 right there, and 1 is also odd. You know what? I'm going to have a negative divided by a negative. What is a negative divided by a negative? I'm going to now, if this was multiple choice, which your provincial mostly is, I would cross out any negative answers with a smile on my face, and I would say, nice try. Okay? And some of your tests will be multiple choice as well. I'm not a fan of them, but since the provincial is made up like that, in fact, I'm going to go like this. Gone. We already looked for power to a power. Now we're going to walk through this one term at a time, looking for negative exponents. Okay? So we're going to go like this. That 32, is there a negative exponent on it?
No.
Leave it. A squared, leave it. B to the negative 4, put it on the elevator. Yes? I'm going to go to the bottom of the first fraction, that 4, leave it. A to the negative 8, elevator. B to the negative 2, elevator. So far, so good?
No, wait, why did A go up?
Elevator.
Oh.
Right? I think I've done, and that's why the B to the negative 2 became a B squared up top. Okay? Times, now when you multiply fractions, what you're really just going to do is top times top, bottom times bottom. In fact, I kind of see this as one big top, so I'm just going to put stuff here. This 8 is going to stay on top. What about that A to the negative 2? Elevator, become an A positive 2. And then there's a 3, that's going to stay on the bottom. Yes?
Yeah.
And a B to the negative 3, elevator. Let's tidy this up a little bit. Numbers on the top, can you see I got a 32, I got an 8. It's going to be 32 times 8, which is 256. Yes? How many A's on the top grand total? I see 10 of them. Yeah? How many B's on top grand total? I see 8 of them. No, 5 of them. On the bottom, numbers, see the 12?
Yeah.
Yep. Nice. And I have 4 B's on the bottom and 2 A's on the bottom. Okay. We've tidied this up. Now, numbers first. 256 over 12. Does that work out evenly? That's my first question. My gut is saying no.
No.
Okay. What goes into 256 and 12 evenly? The first thing I would try is 2. If you divide by 2, you'll get 128. And if you divide by 2, you'll get 6. Is there something that goes into 128 and 6 evenly?
I mean,
2 again. They're both even. Yes?
oh,
Yeah. So I would then divide by 2. Yoink. 64. Divide by 2. 3. I don't think there's something that goes into 64 and into 3, because 3 doesn't go into 64. 3 is prime. Nothing goes into 3 but 3. In other words, as a fraction on the top, Kenzie, there's going to be a 64. On the bottom, there's going to be a 3. You saw how we got that okay?
Yeah.
Awesome. How many A's on top grand total? 10. How many on the bottom grand total?
2.
How many left where? How many A's will be left and where? How many on top?
8
Where?
on the top.
Yep. How many B's on top?
3. I mean, no, 6. No, wait.
How many
One.
B's on top?
One.
How many B's on top?
Oh,
5. How many on the bottom?
4.
How many left and where? You were doing the final answer. 1 on top. Yep. Am I going to write the 1? No. Is that the answer? 64, A to the 8th B over 3, I hope? Okay. Some of you may be at a stage where you could take a couple of shortcuts there. You know what, Sarah? In the homework, I try and push myself to take shortcuts. On a test, I would show extra work and be extra careful, or on a quiz, yes? Hopefully I've taught you that by now. Is that okay?
Yeah.
And you said 13? Which one? By the way, so I'll let you try B. B, you're going to have a power to a power. That 3 is going to go onto there, and onto there. By the way, look at this last term. What's negative 3 times 0? What's anything to the 0 power? 1. That was the rule we reviewed last. You can kind of ignore that. R is going to just vanish. It's going to be a 1. Not an R to the 1, just a 1, right? You're going to have a power to a power in the bottom. It's going to go onto there, onto there, onto there, onto there. And then I don't see any negative signs, like no negative numbers. I see negative exponents, elevator them to death, and then how many on top, how many on the bottom. Is that all right? 13, which one do you want me to do? I'll do one of them. F looks uglier? Sure. Power to a power? Do I have a bracket with an exponent outside?
Yeah.
That's what I look for first. So this negative 2 is going to go onto, not onto the 12, onto the exponent right there, which is an invisible what? 1. I'm going to get this. Dunk. 12 to the negative 2. Dunk. X to the negative 6. Yes, yes, yes. And then y to the negative 1 times negative 2 is positive 2. All over. Hey, see this negative right there? What's the exponent acting on this negative right there? Negative 2. Odd or even? Vanish or stay? What's going to happen with that negative?
Oh no,
Go. So I'm ditching the negative, yes? It's going to be an 8 to the negative 2, but not a negative 8. An 8 to the negative 2. An x to the power to a power positive 2, negative 1 times 2. And a y to the negative 10. So far, so good? Let's put an equal sign right here. Have we taken care of power to a power? Yes. Have we figured out, Kirkland, whether the negatives are going to stay or going to go? Yes. Now let's deal with elevators, negative exponents, negative exponents. What's going to happen to that 12? Stay or move to the bottom? Convince?
Yeah.
Why? What's the exponent on that 12?
Negative. A lot.
Okay. And become positive. Now, Kenzie, look up. Hang on. I want to save us one line. I was going to write that, but what is 12 squared? What is 12 times 12? Can I write that right away? Save us one line. There's going to be 144 on the bottom. There's going to be an x to the 6th on the bottom, elevator, yes? That y squared, Rachel, is going to stay on the top. Yoo-hoo! Right? What about that 8 to the negative 2? What's going to happen to it? And going to become an 8 squared. Can I write something instead of an 8 squared? What? Can I do that? Thank you. What about that x squared? Stays. Right? What about to that y to the negative 10? Elevator. Is that okay so far, Kenzie?
Yeah.
Okay. We have 64 over 144. I need to reduce that to lowest terms. What goes into 64 and 144? Try 4. What's 64 divided by 4? What's 144 divided by 4? I think it works out evenly. 36? Oh, I can go further because I got a 16 and I got a 36 on the top. What goes into 16 and 36 evenly? 4 again. Divide by 4, 4. Divide by 4, 9. You know what, Katie? My final answer is going to have a 4 on the top and a 9 on the bottom. Now, how many y's on top, grand total? How many on the bottom? How many left? Where?
8.
How many y's on top? You said 12. How many on the bottom?
Oh,
None. So how many left and where? On the top, right? How many x's on top? Trick question. None. How many on the bottom? Can you see it? It's going to be 8 left on the bottom. I hope that, is it 4y to the 12 over 9x to the 8? Yeah? 13f? Okay. And again, am I going to give you 10 of those on your test, Kenzie? No, probably 1. Is that okay? If you have more questions, I'll take more later, but we need to get a big chunk of the lesson. And this is where, for this unit, Mickey, Math 10 starts, so you want to put your phone away. This is new. I don't think any of your teachers looked at this last year. The title here says Rational Exponents. Do you remember what rational numbers were? They rhymed with something which told you what they were. Rational numbers were numbers that were also what? You could write them as a fraction. Rational and fractional, Katie, sort of rhyme. What we're going to ask ourselves, we've avoided this very carefully the first 14 years of your existence. What happens if the exponent is a fraction? And this is why I wanted you to get your calculators out. It says, on your calculator, example 1, evaluate the following. Now, we're going to go 25 to the 1/2. You got a problem here. Look up for a second. If you type 25, press your exponent button, and you type 1 divided by 2, that won't work. Your calculator will think that the 1 is an exponent, but it won't know that the divided by 2 is an exponent. To tell our calculator that the whole thing is an exponent, what you'll need to type is 25, press your power button to the power of your x to the y, your hat, depends on what it is on your calculator. And you have to go bracket 1 over 2, 1 divided by 2, close bracket. You could put in 0.5, but some of the fractions don't work so nice as decimals, so I'm teaching you how to do a fractional exponent. And also, like 1/7, for example, is 8 decimals long. It's way easier to type 1 divided by 7, trust me. What'd you get? 5. Hey, what's 49 to the 1/2? What?
7.
Did you try that, or did you spot a pattern and make a huge leap and conjecture?
Just saw that 25 was 5, so 49.
Can you make a prediction for me then, Karn? What do you think 9 to the 1/2 is without a calculator?
3.
So complete the following. X to the 1/2, what's that the same as? Which mathematical operation that we spent a fair bit of time on last unit is that the same as? I heard someone say, what? Square root. Turns out this is the same as that. Who's got the really cheap POS calculator? Not not Carmelina's, the scientific one that I've really made fun of. No, yours is a little better. I think it's in my other block. Katie? No? Nope. Might have been. There is one calculator. You may remember last unit we were doing 4th roots and cube roots and 5th roots. Someone had a button and instead it didn't say this. Instead, it said it had a fractional exponent button because to the 1/2 is the same as square root. Okay. Hey. Let's see if we can take a guess, spot the pattern. On your before we go to our calculator, what do you think 8 to the 1/3 power might be? Why 2? If we were looking for a pattern, if a fractional exponent had a 2 on the bottom, that meant square root. What would be a lovely pattern if a fractional exponent had a 3 on the bottom? What kind of a root? Cube root. Try it on your calculator, but I'm pretty sure you do get a 2 there. I'm pretty sure if you go 27 to the power of bracket 1 divided by 3, you get a 3 there. And I think you get a 5 there. In fact, complete the following. X to the 1/3 is the same as the cube root of x, putting that 3 inside the little v of the square root there, the index. All right, smarty pants. What do you think 16 to the 1/4 is? If fractional exponents are roots, what do you think a 4 on the bottom gives you? What kind of a root? So let's write this down. This is going to be the 4th root of 16. And now, Kenzie, you have 2 different ways to evaluate this. Some of you may know where your 4th root button is. Mine's over here. and I've taught you how to do that. Or if you can't remember how to find your fourth root button, you can always go 16 to the power of, that's fourth root. You get 2, yes? What do you think the 1/5 as an exponent is? 32 to the 1/5, the next one. What do you think, what kind of a root do you think that is? What is the 5th root of 32? Either use your 5th root button, or you may find it easier to type 32 exponent button bracket 1/5 close bracket. Also 2? I get it, Mr. Dewick. The answer is always 2. No, I was just making up small number examples because I didn't want to scare you guys. Hey, what do you think 243 to the 1/5 power is? That's going to be the 5th root of 243. I think this one still works out evenly because I was trying to make it, does it? I hope. They may be decimals, by the way, because I don't always have to make them work out evenly. I don't always have to use a perfect 5th or a perfect cube or a perfect 4th. 3? Yeah? So here's our new exponent rule. It's the fractional exponent rule, and it says if you have a base x, but your exponent is a fraction, you can rewrite this as the nth root of x. X to the 1/8, Mickey, is the 8th root of x. You know what x to the 1/10 is, Brendan? The 10th root of x. And this is why sometimes, so whoever borrowed my graphing calculators, you won't find an nth root button because they assumed that if you wanted to find the 8th root on that calculator, you would just type the number to the power of bracket 1 divided by 8 close bracket, and they felt it was a redundant function. Why bother including it? And there's some truth to that. So we're looking at fractional exponents. Sarah, do you notice the fractions that we used for exponents? What was the numerator in each of those fractions? What was the number that I put on the top of the fraction? 1. The next question we're going to ask ourselves, Mr. Smarty Pants, is what if there's not a 1 there? But let's turn the page. It says, write the following in radical form. So if I want to write this as a radical, 100 to the 1/2, if not the answer, they didn't say evaluate, they want me to write it as a radical first and then evaluate. What's 1/2 as an exponent the same as? What root? What radical? So we could write this as square root of 100 and then evaluate. Hey, what's the square root of 100? 10. 64 to the 1/3. If I said, could you please write that as a radical, what root is that? That's the same as the cube root of 64, which is what? 4? Ooh, Mr. Dewick. Kenzie, my child, in this third example, do you see a bracket with an exponent outside? Then let's do power to a power. What would we do with those two exponents? What was the rule? If I gave you this, x to the 5th squared, is the answer x to the 7th or x to the 10th? What did you do with the 5 and the 2 then? What are we going to do with the 1/2 and the 1/2? Okay, so let's write, because this is a weird one, let's show extra work. This is going to be 256 to the power of 1/2 times 1/2. And you may have picked up the hint that I dropped last class. I said multiplying fractions is the easiest operation. It's top times top, bottom times bottom. 1/2 times 1/2. What's 1 times 1? What's 2 times 2? This is 256 to the 1/4, which is what root of 256? 4th root. Which works out to what? I think 4? Okay. So we can even, you know what, actually the power to a power rule for fractions isn't too bad. Top times top, bottom times bottom. Oh, and if you get something like 2/6, reduce it to lowest terms, 1/3. If you get something like 5/10, don't go to the 5/10, 1/2. Let's do a couple more. Let's do some algebraic ones. Write the following in radical form. X to the 1/2 is the same as if I wanted to write that as a radical with a root symbol. How? What root? Square root. How would I write b to the 1/3 as a radical? Cube root of b. That 3 looks a little wonky. P to the 1/10 is which root? 10th root. We don't use it very often, but sure. Of P. Ooh! A to the 1/n is what root? Here's our generic generalized. The nth root of A. And Tawny, you may remember, we always put the number there. You could put a 2 there for square root, but because square root's the most common one, we've gotten in the habit of not bothering to put anything there. If it's blank, we know it's a 2. Just like if there's a 1 as an exponent, we know it's there. We don't bother putting it up there. Some stuff over the years we just got lazy in. So here is our generic rule. X to the 1/n is the same as the nth root of x. Now we come back to the question I asked Sarah a few minutes ago. What about x to the m/n? Hey, what if that top fraction, what if the numerator isn't a 1? Karn was pretty sharp earlier. Let's see if we can figure out this pattern. It says, complete and evaluate the following. The square root of 5 cubed times the square root of 5 cubed equals. Okay. Ready? There's a couple of ways we can do this. The first way is for us to say this is the same as the square root of 5 cubed times 5 cubed is 5 to the 6th. When you multiply, you add the exponents. Okay. Now what, Mr. Dewick? Well, there's another way for me to do this. Put your pencils down and look up. Oh, wrong button. Let's try that again. Right button. Do you remember what the square root of 3 times the square root of 3 worked out to? Just plain, it was root 9, which just ended up being 3. When you multiplied a root by itself, the root just vanished. Right? What was the square root of 7 times the square root of 7 equal to? What about if I had root 7 squared times root 7 squared? What if I had root 5 cubed times root 5 cubed? Another way to think about it is just that. Then it says, deduce a meaning for 5 to the 3. We'll come back to that. See, there's another way that we could do this here. We could go 5 to the power of 3 over 2 times 5 to the power of 3 over 2. What's happening right there, Mac? What's happening right there in the middle? Times. Are my bases the same? So what do I do with the exponents? What's our exponent rule for multiplying? We don't multiply the exponents. Remember what we do? What do we do? What do we do? Mac, what do we do? Look up. If I give you this, what's the answer? Okay. Not 28, 11. What do you do with the exponents? So, ready? Scene 1, Act 1, Take 2. What am I going to do with these exponents here? What am I going to do with I'm looking for one word, begins with letter A, ends in 2 Ds. We're going to add the exponents. That's all I wanted to get out of you. Okay? So let's try that. I could write this as 5 to the 3 over 2 plus 5 to the 3 over 2. Are we multiplying those two fractions together? No, we're adding. Now, adding fractions, Kenzie, is the most complicated operation. That's where you had to find a common denominator. Do I have a common denominator already? Are they both over 2? Yeah? Then you know what 3 halves plus 3 halves is? How many halves? Yeah, just like 3x plus 3x is 6x's. 3 halves plus 3 halves. You know what? This is... And what is 6 over 2 in lowest terms? 3 over 1, right? 6 over 2, 3 over 1. Curtis, here's what I want you to notice. Did I get the same answer? Then, if I got the same answer, doesn't that mean that that is the same as that? Yeah? And when it says deduce a meaning for 3 over 2, where'd the 2 come from? What root is this? What root is this? Square. Where'd the 3 come from? What's the exponent on the number inside the root? 3. You guys with me? You guys are looking a little out of it. Let's do another one. It says copy and complete and evaluate the following. The cube root of 2 squared times the cube root of 2 squared times the cube root of 2 squared. This is going to end up being the cube root of 2 to the 6th, because you would go 2 squared times 2 squared times 2 squared. And when you add the exponents, you would go 2 plus 2 plus 2, 6. Or another way to think about this is this ends up being 2 squared. Say what? Yeah, it does. Ends up being 4. Mickey, my angel, what kind of a root is this? So if I was writing that as a fractional exponent, what would be on the bottom of that fraction? A 3. What's the exponent on the 2? A 2. What's the numerator of this fraction? The numerator, the top. 2. 2. I don't know if I'm losing you guys or not, but I'm going to turn the page because it looks like the explanation. Here's what we want you to realize. Okay? Sarah, you've already pointed out that the denominator becomes the root. You know what the numerator becomes inside the radical? The exponent on what's inside the radical. If I want to write x to the 5/3, it's going to be the cube root of x to the 5th. How would I write b to the 4 over 5 as a radical? The what root of what to the what? Sorry? 5th root of b to the 4th. How would I write p to the 5 over 2 as a radical? The what root of what to the what? Square root. You could put the 2 there, but we understand if you leave it blank, it's square root of p to the 5th. Now, as it turns out, Karn, we have an option here. That exponent, that 5, we can put it anywhere. Look up. I can put it right there, or I could say do the root first and then find the exponent. I traditionally write the exponent like that. Let's generalize. Ready, Jordan? See the 4th one there? See your base? What's the base? What's the exponent? Did you say a fraction? We can write this as a radical then. There's going to be a radical sign. The base is a. What root? Nth root of a to the m. Grayson, you see it? You know what the most common mistake is? Kids know that a fraction becomes a radical, but they can't remember whether the top goes inside the square root symbol or the bottom goes inside the square root symbol. So here's Mr. Dueck's stupid way to remember this. I'm going to show it to you. Don't write it down. We're going to write it down later on in the notes. Suppose I gave you this. 8 to the power of 5/3. Grayson, is that a fractional exponent? Then you know it's going to be this. The real question is what goes where. So here's what my teacher taught me way back when in math. Don't write this down, Curtis. We'll write this down in our notes later on. Flower power. What's that say, Grayson? Loudly. What's that say, Mac? What's that say, Hayden? Sorry? Yeah. Here's what my teacher said. She said, hey, this fraction looks kind of like a flower. There's the flower. There's the root. Put the root to the root. Put the flower to the power. Flower power. That's how I still do it all these years later. When you give me a fractional exponent, Katie, I go, the root goes to the root. The bottom goes to the root. And the power goes to the flower. Flower power. Pick your pencils up. Evaluate, it says. 8 to the 1/3 squared. Okay. Is there a power to a power? What am I going to do with those exponents then? Not flower power yet. No, sorry? Multiply them. So this is going to be 8 to the 1/3 times. Now, I want to write 2 as a fraction because I'm multiplying fractions. 2 is really 2 over what? No. When I gave you this, didn't you tell me it was x to the 20th? You didn't put anything in front of the x, did you? Right? So why would you do it with an 8 just because there's a number there? Same rule. Is that okay, Brennan? Yeah? So back to my comment, I'll make that a fraction. How do I multiply fractions? That's the easiest operation of them all. Top times? No. Top times? Top. Bottom times? So this is really going to end up being 8 to the what? Over what? Flower power. This is the same as the 8's going there. The root to the root. Cube root. Flower to the power. And you can do this in your head. Really? No calculator, Mickey. I'll show you what I mean. Mickey, without a calculator, what's the cube root of 8? 2. Squared. Oops, that wasn't supposed to happen. Lost everything there. Let's try that again. What's the cube root of 8? Squared. 4. This works out to 4. This will be, because I told you on your provincial exam there's a non-calculator section. This will be some of the questions they can ask you to do without a calculator. They can give you a yucky fractional exponent. Best way to do it is rewrite it, flower power, as a radical. Find the cube root or the 4th root or the square root or the whatever, and then take that answer and whatever exponent's left. B. What about 8 to the 2/3 times 8 to the negative 2/3? Well, there's 2 ways to think about this. Carmelina, what's the base in this question right here? 8. What's the base right here? Are my bases the same? I'm multiplying, Mac. When I'm multiplying, what do I do with exponents? I'm looking for a 3-letter word that begins with the letter A. So I could say this. This is the same as 8 to the 2/3 plus negative 2/3 when I add the exponents. Yes? because there's a negative right there. Hey, what do you think 2/3 plus negative 2/3 is in your head? Too slow. What's 5 plus negative 5? Too slow. What's 1 plus negative 1? What's 5 plus negative 5? What's 10 plus negative 10? What's anything plus negative itself? What's 2/3 plus negative 2/3? And what's anything to the 0 power? There's a second way you could have done this. You could have said, same question. Hey, Mr. Dewick, I see a negative exponent. Do you see a negative exponent? Is it a negative exponent? Say yes. Is it not? Karn, is that an exponent? How do you know? Because it's up written high? Is it negative? How do you know? It's got a negative in front of it. So back to my first question. Is it a negative exponent? Absolutely. Elevator. I could rewrite this and I could say there's going to be an 8 to the 2/3 on the top over there's going to be an 8 to the 2/3 on the bottom. I moved it to the bottom and ditched the negative. What's on the top of this fraction? Read it to me, Karn. What's on the top of this big fraction? Read it to me. 8 to the power of? No, 8 to the power of? What's on the bottom of this fraction? What's 5 divided by 5? What's 10 divided by 10? What's anything divided by itself? Except it's 0, but we're not going to. So what do you think 8 to the 2/3 divided by 8 to the 2/3 is? Just showing you two different ways you could evaluate that and get the same answer. You could add the exponents, Rachel, paying attention, of course you are. Or you could write it as a fraction using the negative exponent elevator rule, and you get the same answer. And this brings us to today's big rule. This is what you want to draw a big star around. I'm going to highlight it in multicolors. This is where Math 10 exponents begins. This is the rational exponent rule. A to the power of m over n, flower power, is the nth root of a to the m. Mr. Dewick, yeah, Ty. Why'd they write this twice, once with the m outside and once with the m inside? Ty, what they're saying, Ty, you alive?
Yep.
Good. What they're saying, Ty, is it doesn't matter if you do the exponent and then the root, or if you do the root and then the exponent, you'll get the same answer. I usually do the root and then the exponent, because if I take the square root or the cube root, I end up with a smaller answer, and then I can do the exponent in my head. Oh, we have to add some conditions. M and n both have to be, what did the capital letter I stand for? Do you remember? Integers. You can't have a decimal inside of a fraction inside of an exponent. This rule doesn't work then. Oh, and I added one more restriction. What can't a be? 0. Why not? What's the square root of 0? 0. What's the 5th root of 0? What's the 10th root of 0? What's the infinitieth root? 0 doesn't behave like the rest of the roots. So we say, let's just please remember this doesn't work for 0. Okay? Also, if the denominator n is even, then a must be positive. Say what? Can you take the square root of a negative number? No. Can you take the 4th root of a negative number? No. Can you take the 6th root of a negative number? No. All of those are fractions that have an even denominator. Ah! Nothing? Oh, Nate, what if the fractional exponent is negative? Oh, how does a negative exponent behave? It acts like what? It acts like an. Help me out, folks. How does a negative exponent behave? It acts like an elevator. You better do the homework from last class. You haven't done the homework from last class. In other words, my lesson where I borrowed this from is giving this to you as a separate rule, this also. I really don't use it. If you give me that as a negative exponent, I'll just put it on the elevator. Oh, and now I'm good to go. I'll have the root in the bottom now. Thank you very much. Or the root in the bottom now. Thank you very much. Where m and n are, again, Carmelina, both integers, and a can't be 0. And if the denominator n is even, then a must be positive, because you can't take the square root, or the 4th root, or the 6th root, or the 8th root, or the 10th root. You can't take an even root of a negative number. Let's try applying some of this. Oh, Mr. Duick's stupid way to remember. Think of the fractional exponent like a little flower, with the top being the flower poking out of the flower pot, and the n being the inside the flower pot, the root. Flower to the power, root to the root. And that'll help you keep straight what goes where. If you come up with something better than that, let me know and I'll change how I teach this forever. But I'm blatantly stealing this from my Math 10 teacher, who was very good. Must be. I still remember it like 20 years later. Well, 18 years later. Let's try applying some of this. Example 8 says, verify the following in radical form and then evaluate without using a calculator. We'll see if we can do these in our head. We'll check our answers on a calculator if necessary. You ready? Example A. What's the base, Curtis?
25.
Is it a fractional exponent?
Yeah.
There's going to be a root. Flower to the power, root to the root. What root? Square root. Do I need to put the 2 there? No, you can if you want to. Cubed. Now here's how I would do this in my head. I do the root first. Curtis, what's the square root of 25? 5. Cubed.
125.
Yeah. By the way, you could have gone 25 cubed first and then square rooted that. Do you know what 25 to the 3rd power is in your head? I don't. That's why I usually do the root first. Give me smaller numbers. B. 1,000 to the power of 4/3. Put the calculator down. We're not going to. Well, we're right. I'll let you know if we're wrong. I want to get you to do these in your head first, and then we're going to go back and check a few of these. Ready? What root? Cube root of 1,000 to what power? 4. What's the cube root of 1,000? 10. To the 4th. A 10 with how many zeros? 4. C. Before I do flower power, I need to do something else first. Elevator. This 27 moves to the bottom. Now, a lot of kids, when they do that, they want to flip this. Don't flip this. It still is going to stay a 2/3. Do I have anything left on top? Yeah. What am I going to put up there? A 1? So this is 1 over the what root of what? to the what? Cube root of 27 squared. Cole, what's the cube root of 27? What's the cube root of 27, Kirkland? 3 squared. Squared. 9. There's going to be a 1 on top and a 9 on the bottom. This is why I cut Cole off earlier when he was going for his calculator. See, if you check this one out on your calculator, you'll get 27 to the power of bracket negative 2 divided by 3. I don't know necessarily that you'll recognize that that's really 1/9. It is. D. 16 to the power of negative 3/4. Did I say to the power of negative? Yep. Elevator. This is going to be 1 over 16 to the positive 3/4. Flower power. 1 over, there's going to be a 16. The what root of 16 to the what? 4th root of 16 cubed. Okay. Who knows what the 4th root of 16 is without a calculator? 2 cubed. On the bottom, what's left on top still? 1. Couple more. E. Negative exponent? No elevator. Negative number? Yeah. Oh, my denominator is my denominator. The bottom of that fraction, is it odd or even? So we can evaluate this. The top of the fraction, is it odd or even? Even. What's the top of the fraction? Even. Will that negative stay or go? Why? Because the top of that fraction is even, and that's what determines whether it stays or goes. This is going to end up being the cube root flower power of negative 8 squared. And I'm telling you that negative is going to vanish. I left it in here. What's the cube root of negative 8? Negative 2 squared, positive 4. But you didn't need, you could have decided ahead of time, Mickey, I know my answer is going to be positive. We just proved it. Compare that with F. What's the difference between E and F? So that 2/3, is it acting on the negative? No. This is going to be negative flower power on the 8. The what root of what to the what? Which is going to be negative. What's the cube root of 8? 2 squared. G. Can I do this? Yoop, yoop. Let me ask you a different question. Was I allowed to do that a couple of units ago when we were doing polynomials? No? What did I have to do instead? I had to rewrite it twice. Okay, so I can't do that. That's what I want you to realize. Instead, I have to do what's inside the brackets first. Hey, what is 3 squared? What is 4 squared? Hey, what is 9 plus 16? This is 25 to the 1/2. Hey, what's 25 to the power of 1/2? What's 1/2 as an exponent the same as? Which root is this the same as? This is the same as square root of 25. Yes, it is. You're right, whoever that was. Was that you? I thought it came up over here. I'm making fun of you? Oh, that's even better. Mickey, what is the square root of 25? 5. Flower power. To the page. I'm going to get through this whole. I am going to get through this whole lesson. A couple more. Okay. It says write the following in radical form. Write the following in radical form, and then evaluate without using a calculator. Then it says verify. Cole, we're going to skip that step. Okay. Do you see a power to a power? Do you see a bracket with an exponent outside the brackets? Well, then do that first. So that's going to go on to the 9, and it's going to go on to the 4. This is going to be 9 to the 3 over 2 over 4 to the 3 over 2. You with me, Rachel? Let's stay focused. Flower power. Rachel, what's my numerator, the bottom of the fraction on the top there? 2. Which root is that? Yes, nice. I thought you were zoning out, but you're with me. This is going to be the square root of 9, and then the 3 is going to go there. Flower power. And it's going to be the square root of 4, and then the 3 is going to go there. Flower power. Katie, what is the square root of 9? 3 cubed. 27, I think. Did you say 27? Is that what you said? I think you said 27. Over. Hey, let's keep going, Katie. Let's take it all the way bottom. What's the square root of 4? Cubed. This whole thing works out to 27 over 8. And your calculator, Cole, would not give you that answer. It would give you a decimal. And you might be able to convert it back to the fraction. Maybe. Yeah, I think this gets you there cleaner. Yoink. B. Power to a power. 9 to the negative 3 halves over 4 to the negative 3 halves. Now what? Nathan, do you see negative exponents? Yeah? What do negative exponents act like, Nate? What do negative exponents act like? Oh, so are you saying that to make this negative, the top positive, I can go like that? And are you saying I can go like that? You'd be right. Look at the previous question. What did the 4 to the 3 halves work out to when all was said and done? 8 on top? And what did the 9 to the 3 halves, when we went flower power, work out to when all was said and done? 27. Couple more, we're done. I find letters easier than numbers, because numbers, yep.
8 over 27, you can reduce it. Should we reduce it more?
I don't think it can reduce. 3 doesn't go into 8. And by the way, I'm glad you said that, because I think what you were actually doing, Jordan, is you were mixing up the fact that they're both perfect cubes and thinking that means 3 goes into them. Now, they are both perfect cubes. When I see an 8 and a 27, that's one of the things I look for. But yeah, they don't reduce. Hey, let's do some letters. It says, write the equivalent expression using radicals. Radicals, Kenzie, means use one of these funky signs. Yes? Hey, what letter does that sign look like? A lowercase letter r for radical? Yeah. R to the 1/3. How can I write that as a radical? What root of r to the what? Cube root of r. Do I need to write the 1? I'm not going to. B. The what root of what to the what? Flower power. 7th root of s to the 4th. C. Before I flower power, Nate, what does a negative exponent act like? So are you saying the first thing I would do is move the t to the 1/6 to the bottom, make it positive? I agree with you. And then that's going to be 1 over what root of what to the what? 6th root of t to the, I'm not going to write the 1. Try d on your own. Try d on your own. You get 1 over the square root of v cubed. Sorry? No. As long as, Mickey, you put the 2 right inside that little v right there, and not in front, because in front that meant something different with radicals, right? We did that last unit where we had the coefficients. Last one, we're done. It says, consider the following powers. Let's go to our calculators. Let's try typing these in. So the first one is going to be 64 to the power of bracket 2 divided by 3, close bracket. When I hit enter, I get an answer. Okay. By the way, I heard Brendan say, can't I use 0.666? I would just type as your fraction 2 divided by 3 as your exponent, because otherwise you're rounding off using decimals, and it's less typing. So what's the answer to A? What's the answer to B? Well, to do that one, I would go bracket negative 64, close bracket, to the power of bracket 2 divided by 3, close bracket. And I get also positive 16. For C, I would go 64 to the power of bracket 3 over 2. And I get 512. Try D. What? You should get a math error or an error or a syntax error. Your calculator should barf at you. Okay? No solution. Why? The easiest way to explain this is to flower power all 4 of these really, really quickly. The first one is the cube root of 64 squared. And I can take the cube root of 64, no problem. The second one is the cube root of negative 64 squared. And I can take the cube root of a negative number, no problem. The third one is the square root of 64 cubed. And I can take the square root of 64, no problem. The fourth one is the square root of negative 64 cubed. What's wrong with that? You can't take the square root of a negative. So I could have spotted that if I was really paying attention ahead of time, Kirkland. I might have said, you know what? That's a square root of a negative in disguise. My calculator is going to barf at me. I think I gave you a lovely little dumb math comic there, yes? On the next page? And I think I've told you why I like Foxtrot so much, because the math is correct, yes? What's your homework? I have an assignment to give you. Here we go. What's your homework? I think I'm going to go number 1. Which ones? How about F, G, and H? Number 2, oh, they're using negative fractional exponents. I'm going to say, how about F, G and H. Number 3. How about C, D, and E? When it says without using a calculator, what it's saying is if you use flower power, the numbers should be small enough if you've memorized some of the roots and some of the exponents that you should be able to get there all the way in your head. You can always check your answer. Skip 4. Five, let's go, or sorry, 6, let's go. How about yoink that row there? No, I take that back. Sorry. Don't erase yet. Just wait till I'm gonna say, how about this batch here? Okay. That's got some negative exponents and some positive exponents. I've skipped 5. 7. 11, 12, and 13. Okay. So I signed 6, those ones, 7 all, 11 and 12, 13. Sounds like a lot, but you got a whole week. Now, when do I see you folks next? Well, Thursday for the basketball game, but then I officially see you folks Tuesday. We'll be finishing off the unit on Tuesday. Next week, Thursday, be a review period. I think the week before Christmas, we'll do a test, and that way you'll have no homework for the Christmas break. Okay?
Yeah,